Hello everyone, welcome to MLAS 800, Integrated Machine Learning and Autonomous Systems. We're going to be going through the course intro today, as well as an overview of intelligent autonomous systems, and then we'll jump into a quick overview of cybernetics. So let's go ahead and jump into course intro. So this is MLAS 800. This is course numbered 12327. 3 credit hours. We're instruction mode. We are online course. Started this week, 6/3/2024. Will be ending 7/26/2024. I do have a note on that for the assignment, so I'll circle back on that here in a couple slides. So of course, my contact information. I am Dr. Michael James Pritchard. My phone number is 785-979-0706. You can text me, or you can email me at mjp001@ksu.edu. Definitely both work and work great at being able to get in touch with me pretty quickly. As far as textbooks and class resources, we will be using OpenAI a little bit, GPT-4. We also have Anaconda that we might dabble with as well. But there are some other resources that I have available that might make our lives a little bit easier. We'll be working with LM Studio for our large language models. And then we may use the Google's Colab environment as well. So there might be quite a few. There's a lot of new tools out there. So really what I'm saying is I don't want us to be restricted just to the OpenAI / GPT-4 LLM that is so famous and pervasive that you keep hearing about in the news. So there will be some other software packages that we'll explore as well as we move through the course. Any materials that are going to be any type of digital content or learning content, I'll supply those. There won't be any additional cost to that. And then so just be on the lookout for that. Again, I'll just make that available in Canvas. Okay, so as we get to the course, high level, this you can think of this course as really being focused on two really big concepts, of course. Autonomous systems, and then artificial intelligence at a really high level as it relates to autonomous systems. So really, it's an intelligent autonomous systems, and that's really what we mean by integrated machine learning and autonomous systems. So that's a good descriptor is that they're just autonomous systems that are intelligent. So we'll be covering that in the topics in the course schedule. We'll be covering this week. We're going to be, of course, covering this the course intro and where things are at and how to get there and where you can find assignments. There are 2 assignments, and I'll talk a little bit about that as well. But then we'll also go through and talk about what is an intelligent autonomous system in a little bit more detail, and this idea of second order cybernetics as it relates to that. That'll be week 1, and with a little bit of a primer there'll be 2 lectures this week, and an intro to GPT-4 and large language models. Maybe more focused on just an intro to large language models, specifically with GPT-4 being kind of a bit part player in that whole arena. Week 2, we'll get into a little bit of lecture lab format. We'll be talking about different types of data that can be scoped in as it relates to large language models, or even a discussion around large multimodal models, which is LMMs. And then we'll kind of go through a little bit of data collection prep, and then we'll talk a little bit about introduction to API and interfaces. And by next week, we'll probably be into a bit of a lecture lab focus. This week will be strictly lectures, and then you'll be working on getting your environment set up on your PC from this week into next, and then we'll probably be hitting lab in the second half of next week, and then that'll get us into prompt engineering and creating prompts for perception tasks and prompts for manipulation, and then we'll have so there'll be a little bit of prompt engineering in the middle part of the semester. It very much is it's just kind of like I was saying in the Canvas course messaging announcements, that the nature of autonomous systems has really changed with the advent of large language models, and how fast artificial intelligence has moved in that realm. And we'll be dispelling a lot of the architectural underpinnings will be of large language models. We'll be jumping into the architectural context, in addition to the hands-on work we'll be doing a little bit. You do not, just as FYI, you do not have to be a coder. You don't have to be a programmer or a computer scientist. This course is built to be standalone with everything that we need here. So I'll make sure that we cover all the necessary tasks and all the necessary skills and widgets that we need. I'll make sure that they're covered, and that you're not having to go too far from what it is that we're trying to cover in this course, and self-contained within this course. All the skills will be fine in that respect. Okay, so week 4, that's when we get into the midterm design proposal submission. The assignments have been pushed up. So there's 2 assignments. There's the midterm design proposal document, and then there's a final design presentation deck. And those are the only 2 assignments we've got for this semester. And if just make sure you're putting your thinking cap on, make sure you're doing the assignments and keeping up with the lectures and labs, and you'll do just fine. So, but if you have any questions on that, definitely don't hesitate to reach out to me and get any clarifications you might have for those assignments. On week 5, we'll be getting into getting those interfaces developed in automation pipelines and conducting tests. And then we'll just do LLM testing analysis, and then and how do you get into system testing, and some of that stuff you'll be able to actually see early on. You'll be able to devise your own tests. It's kind of interesting working with large language models. And then week 7 will be testing on real world data, like classification experiments, as well as other types of integration experiments that we can do. We can't get too crazy in operationalizing our autonomous system that we're going to develop. A lot of it will be circular, in the sense that we'll be creating a large language model internally on our own laptops, and downloading one, and then with what's called a vectorized or a quantized large language model that's really compressed and able to run on your laptop and or home PC. And it's a little buggy. I mean, it's a new area, right? So getting these kind of new technologies working. But with that said, as an example, I had some trouble getting some stuff working on my laptop, but I was able to get it working on an older gaming PC, a gaming rig. And it's an older rig, but it is possible, right? And so it's pretty straightforward and pretty neat once you get it working. And then I'll let you run off for the next couple of weeks. Even though we're finished at the end of July, the next couple of weeks I'll allow the design presentation to be submitted post week 8. So that, but it's due no later than August 9th. So, of course, I'd like for you to get it done by week 8, but you have a couple extra weeks past week 8 to get your work in if you want to make any refinements. Okay. So later missing work, there's the 2 assignments, the midterm assignment and then the final design presentation. And you can submit the work anytime, all the way up until the end of the semester. So any later missing work, again, you can have me take a look at it ahead of time for a read-ahead review. And that can be done, of course, ahead of the assignment's proposed due date. But then I can also review and regrade anything that all the way to the end of the semester. So if you're not exactly happy with what you got and you want to redo and adjust your work, I'm happy to review. And it's a learning process, right? That's how this works. So you can submit your midterm and final design and get more points out of it through a regrade process. So just let me know. Easy, and it's not a problem to review and adjust, and we'll make it work. So okay. So how to contact me? Again, Michael Pritchard, 785-979-0706. That's my cell. You text me, and I'm usually pretty responsive. But also you can email me as well if that works out for you. Give me some time to respond back. I've got a lot going on, so with 48-hour turnaround, usually I'll be able to get back to you. If you want to schedule a Zoom call as well, that's fine, or a Teams call, that works as well. Okay, that's all I've got. The syllabus and the details of the syllabus, that's the high level for the syllabus itself and a quick course intro. And now we're going to jump into actually doing, let's do some coursework and get into it with intelligent autonomous systems, and then we'll wrap up with a high level on cybernetics. So what is an intelligent autonomous system? And so this is a big part of our course, right? It is the part of our course. Well, if you back up like 10 years ago, it's not really well known, and even further back, 15 years ago, it's not very well known. But there was a conference, and still is a conference proceeding called Intelligent Autonomous Systems, and it's the 16th International Conference of that. It's held. It's managed by Springer, which is a reputable journal publication framework. They publish quite a few high-end items, and it's a very it is an established area of research. That's probably the best way to say that. And intelligent autonomous systems is as we'll see, it's getting some legs to it over the last few years. And when we're talking about an intelligent autonomous systems, it's a system that's capable of performing tasks that do not have human intervention. And so even something as simple as a cute bot that has two wheels and a little rotator ball on the front that does a line following exercise is considered an intelligent autonomous system. And you program it, and then it can follow a line. And these are tiny little robots that we use with MakeCode, Microsoft MakeCode, block coding strategy. And that's a very basic intelligent autonomous system. So they do exist in very small forms, but they also exist in more complicated forms. Like you'll see them in drones, you'll see them in robots, you'll see them in all kinds of stuff these days. Autonomous vehicles, like Tesla autonomous driving, right? There's different levels of autonomy, and the ability to operate independently without humans is a big part of what makes an intelligent autonomous system characterized as being intelligent. And then usually an intelligent autonomous system is going to have some form of AI and ML under it. It's going to have some sensory capability, being able to do data processing, either with data processing of vision systems. It can be laser, LiDAR, it can be radar, and it has some decision-making capability with it. And it also should have an ability to communicate across systems, not just with humans, but across systems. So oftentimes, more advanced, highly advanced intelligent autonomous systems are going to have the ability to communicate to either for navigation or for system diagnostics, health monitoring, and I would say operational tasks that are part of its requirement. So whether that's a welder robot at a a manufacturing plant, or a drone that's flying over and doing intelligence and surveillance and reconnaissance in an area. There's got to be a communication framework that integrates that autonomous system into the broader data fabric that is the computational engines, right? Whether that's the cloud, or whether that's the organizational's data system, whatever, it has to have that ability to communicate. Okay, so whoops, I jumped ahead. So yeah, and so no, that's where we need to be. So and just to put a more a little bit more emphasis, I don't want to forget that the Department of the Navy put out this really interesting paper on intelligent autonomous systems science and technology strategy, and it was back in 2021. And it just shows how serious it's risen to a level that the government is very interested in this, and has been for some time, but they actually call it out as intelligent autonomous systems. So there's a whole growing community, both on the commercial side as well as on the government side, as it relates to this topic. So last up for intelligent autonomous systems, and then we'll switch over to cybernetics here, is that the applications for this. I've talked about a few of them, robotics, of course, being one of them, defense, UAVs being another. But there are other I should say defense-related uses for intelligent autonomous systems. So smart grids is a perfect example, energy management, balancing supply and demand, and then healthcare in terms of robotic surgery, autonomous monitoring, not just of the patients, but the healthcare, the EHR and the patient record. The admit, discharge, and transfer process has a lot of potential if it were managed by an autonomous system. Agriculture, being able to do surveillance of crops, and being able to, like, for example, automatically capture data on soil moisture, and doing that in austere environments, right? Remote environments that are hard to get to, where there's limited power and there's limited personnel. Intelligent autonomous systems excel in those areas. So it's not all defense, and it's not all aerospace. There's a lot of other areas where intelligent autonomous systems have applications. Okay, so that's all I need to want to run by you at this point for intelligent autonomous systems at a high level. Now it comes to cybernetics. When it comes to cybernetics, I don't want to overdo this. I just want to do a high level, just take a few slides to run through cybernetics with you. And we teach this to our MLAS undergrad students, and we have a very theoretical treatment of cybernetics, a whole course on cybernetic systems theory, and we go through that. We won't go through all that. We're just going to go through the really high level because I want to get you to the large language models, and we'll talk about that in the next learning activity for this week's module. So module 1 for week 1, we'll have 2 learning activities, this lecture and another lecture. So, okay. So as it relates to cybernetics, and why does even cybernetics how does it even intersect with intelligent autonomous systems? Well, they actually are highly influential with each other. The study of systems, control, communication to animals. Really, there was a book, and it was published back in 1948, and it provided the principles in terms of the ideas that inform intelligent autonomous systems. And it was written by a person, Norbert Wiener, and I think is how it is pronounced. And so Wiener, it was republished in 2019, that Cybernetics, or Control and Communication in the Animal and the Machine, by MIT Press. And it's a great book. It's a great read. It really creates the fundamental underpinnings of cybernetics. And it really highly, the principles within it in terms of feedback make its way into intelligent autonomous systems. And so there are a few other things outside of feedback loops, which is a core concept of cybernetics, which is also a core concept of an intelligent autonomous system that makes use of controlled feedback loop systems. There's also the idea of control and regulation within a cybernetic framework. So control theory is very much a part of cybernetics, as again, communication shows up. But feedback, control, and communication feed into this idea of adaptation and learning, which is makes autonomous systems work. It's that last part that makes it really hard, that self-learning and adaptation to an environment that made artificial intelligence increasingly difficult to pursue what we call bodied or embodied system work. It was easier to do in unbodied systems where I could have an autonomous system that didn't have physical moving parts, where it was like, say, a chatbot that I would create within a software system. Those are kind of things that I can create in an online self-learning environment when it's just software. In other words, it's an unbodied autonomous system. But when it becomes physicalized, like I take an AI and I put it in a robot, or I take an AI and I put it in a flying vehicle, then things become a lot more difficult to manage. Not only just the communication and the distance, but the situations that autonomous system will encounter that are harsh and austere, and and cold and dark and different. There's just different environments, and full of rain and full of clouds, or under the water in the sea, and there's just all kinds of different environments. Or even as far as an autonomous system that could be a satellite, a spacecraft, right, or a rover on another planet. So it makes it a lot more difficult. The level of effort to create a more intelligent, or I should say an AI, requires a lot more artificial intelligence horsepower, and a more advanced AI, the more embodied a intelligent autonomous system becomes. So let me say that again. An AI requires more advanced features as the embodiment, as we get closer and more towards embodied architectures. So let's move on to the next piece of it. Part 3, and then we're almost wrapped up here, is that as it relates to cybernetics in intelligent autonomous systems, there's 3 big areas that, of course, we've talked about. The first one, theoretical framework for cybernetics, and then there's 2 things we have to we'll talk about in that here on the next slide. But there's 2 other things. Interdisciplinary research, of course, is a big part of cybernetics. Many people don't know, but artificial intelligence and cybernetics used to be in the same discipline almost 100 years ago. And then they bifurcated out into their own distinct disciplines in the 50s and 60s, when the Macy's conference came out. There was this division that started to happen around artificial intelligence and computation, and then cybernetics, and then human in the loop kind of conversations around cybernetic machines. They're kind of coming back together, this human-machine interaction. And so cybernetics, while AI is more focused purely on artificial computations that lead to intelligence, cybernetics has a human component for machine-human machine and machine-machine interactions. So which makes a very nice complement between cybernetics and artificial intelligence, and that's why we teach them together. A lot of times, not all programs do, but this program does, and we see a nice blending of the 2 disciplines. So last up is this concept of second order cybernetics. And so this will be the kind of food for thought before I send you off to the second learning activity. But second order cybernetics is the idea. There's first order, which is this right here. It's just an input with a cybernetic feedback loop and then an output. But second order cybernetics actually has two loops in the middle. So I still have my input and I still have my output and I still have my cybernetic feedback loop in the middle. But second order has a feedback on feedback that takes into account the observer. So you as the human are in the loop. Whereas in first order cybernetic principles, the human is not in the loop. So a lot of times there'll be distinctions between first order and second order cybernetics. And a lot of times that's kind of more academic distinctions. But I do want to point that out just so from a theoretical perspective, you're aware of the distinction between first order and second order cybernetics. And almost for the most part, it's a matter of perspective. So first order cybernetics is, about the system itself under observation. Second order cybernetics takes a step back and says, okay, now as I'm observing the system, how am I personally impacting the system? How am I as the observer having an impact on being in the loop of this? Or how might other humans be impacting the system under observation? So that brings it up to an organizational level, right? Cybernetics at a second order takes into account, of course, humans in the loop. So that is very much something that I just want you to have in the back of the mind. And one last thing is that in cybernetic systems theory, everything is a machine. And so whether it's an AI that is created by humans or whether it's a brain that is created by other humans, right? A human brain, in other words, your parents creating you and then creating a brain, that is considered a machine within the cybernetics principles. So it's a computationally biological machine, right? And it uses code and it's bound by that. But cybernetics looks at everything as machines. The galaxy is a machine. The Earth is a machine. A car is a machine. Anything that has an input and an output where change occurs is a machine. So, and it's just this idea of it being mechanisms that these things are. That's kind of one of the things that cybernetics is kind of interesting and elegant at in a lot of ways. So you'll hear me talking about artificial intelligence as machines sometimes. And so, and these large language models are no different. They are mechanisms that affect change. They have an input and an output, and a change occurs in the middle. So, okay. So next up, we will talk about that. So we're going to head over to the second video. That wraps us up for our first video lecture. Congratulations. That puts us right at about the 28-minute mark here. And that is perfect because I usually try to keep my lectures between 20 and 30 minutes. Not to say that they don't occasionally go over, but that is for the most part where I'm trying to keep us. So without further ado, I'm going to wrap it up here and let you head on over to the second video. Again, thank you for taking this course. I'm excited to have you here and look forward to next steps.